Hi everyone, we're going to be working on bearings today, which is section 10b.2 in your text. So a bearing is really nothing more than an angle that is measured clockwise from the north direction. So what that basically means is that we're looking at what direction we are moving in. So we are moving in, a boat is moving in, a plane is moving it with respect to its starting point to its end point, or perhaps from its end point back to its starting point. Alright, so a couple of things that we need to look at are that. First of all, bearings are always measured with respect to north, and they move in a clockwise direction. So north being looking upwards, or on your paper again facing up, and we are moving in a clockwise direction. Okay, the second thing we want to be looking at is the wording that's being used, because it can get a little tricky at times. So let's take a look at the wording a little bit here. It says, the bearing of B from A is 25 degrees. Alright, so the bearing of B from A. From A is referring to, the bearing of B from A is referring to starting at A and going towards B. So you're starting at A and going towards B. Alright, so from A towards B in a clockwise direction, if you look at the diagram here, means that I am going with respect to north to the right in a clockwise direction 25 degrees. If I were doing a bearing of A from B, that means that I am starting at B and I'm going to be moving towards A. So that the bearing of B towards A is going to be 205 degrees, again with respect to north, moving in a clockwise direction. And I think it goes without saying that if we are looking at this being north, then this would correspond to 90 degrees. One rotation of one straight line of a straight line would be 180 degrees. If we did 3/4 of a turn, that would be 270 degrees. And if we did one full rotation around, that would, bringing us back to our starting point, that would be 360 degrees. Okay, so let's take a look at one question here. And let's find the bearing of B from A. So a bearing of B from A means that I am starting at A and I am going towards B. So I'm starting at A and I go towards B. Going towards B means going to the line that would take us to B. So here is our line taking us to B, and that would be, therefore, the bearing of B from A would be equal to 58 degrees, or 0.58. One of the things that need to be remembered is that when we are looking at bearings, we're always going to write bearings in terms of 3 digits. So if we have a 2-digit degree, for example, like 58 degrees, we will place a 0 in the front of that to turn it into a 3-digit. Okay, and a 3-digit number, obviously, will just have its 3 digits for the bearings. Now, if we want to look at the next example, which is B from C, what we want to take a look at, so B from C means that we are starting at C and we are going towards B. So we're going all the way around until we hit this B line here now, okay, with respect to C. So before we do anything else, we are going to just do a quick review of the parallel lines and transversals that we talked about the other day, and which basically said that if you had 2 parallel lines, then the internal angles summed up together will add up to 180. So if we take a look at these parallel lines, the 2 parallel lines being the north lines, if I know that the angle internally here is 151 degrees, then that means that the angle internally here would have to be then 180 take away 151, or 180 minus 151, which would give us a 29-degree angle. So that I know that that's 29 degrees. Now, to figure out what the angle here is of the bearing, which is this entire angle that I am indicating right now in red. So this is the angle that I am actually looking for the bearing of B from C, so that I can say, well, 360 degrees, which is one full rotation around, minus the 29-degree angle that we found, would give us an angle of 331 degrees. Now, if we want to find the bearing of C from A, well, the bearing of C from A takes us starting at A and going towards C. Now, our C line is the red line that I have just created here. All right, now, before I can do that, though, I need to figure out what this angle internally is going to be, because that enables me to just add together 58 plus theta will give me the bearing that I am looking for. Okay, so the way I'm going to do this is, well, I could do it in a couple of different ways, I suppose, but what I'll do is I'll try to find the measure of this angle internally. Let's see what we can do. So what I'm going to do then is I'm going to find out what the measure of this angle is here. I'll call it alpha. Okay, and by finding the measure of angle alpha, that'll help us solve the situation over on the other side, on the left-hand side here, to find theta. All right, so because we know that 261 plus 21, so if I add up the angle measure 261 plus 261 plus 29, that's going to give me an angle measure of of 290, and when I subtract that from 360, that will tell me that the angle measure internally of alpha is going to equal 70 degrees. Now, once I know that that's 70 degrees, then I know, again, taking a look at the two parallel lines in the transversal crossing, I've got that this angle internally is equal to 70, and the other angle, therefore, has to equal, oops, not 70, apologize, but 70 plus 29, because this angle here is 70. So this is 70, that's 29, and therefore I know that the entire angle is 99. All right, since it's 99 degrees, that angle, then when I add that up to 58 and subtract it from 180, that should tell me what theta is. Okay, so that, actually, I don't even need to do that, because as long as I know that this angle is 99, I can figure out the entire angle to be equal to 180 minus 99, which is going to be 81 degrees. So I know that the bearing, therefore, of C from A is a total of 81 degrees. So I didn't even need to find theta in this case. As long as I found out what this angle was alpha plus the 29 degrees, then by using the two north lines in the transversal, I could figure out very quickly what the bearing of C from A was. So it's actually 81 degrees. All right. Let's just take a look very quickly at a couple of examples. So one of the examples that I'm going to look at with you is we've got A, B, and C are three ships, and the bearing of A from B is 45 degrees. The bearing of C from A is 135, so that if AB is 8 kilometers and AC is equal to 6. What's the bearing of B from C? Okay, so starting out by drawing out what the problem is asking us is probably the most difficult part, and the rest of it becomes far more simple. So we have A, B, and C are 3 ships, and the bearing of A from B is 45. So starting from B, because it's the bearing of A from B, I start at B. So starting at B, the bearing is going towards A, 45. So I say it's 45, and this is where my value of A is. Okay, and that was a bearing of 45, and here is my with respect to north. That's my north line. Now the bearing of C from A, so starting at A, the bearing is going to be 135. So with respect to north, again, starting at A, we're going to do 135 degrees, which is approximately this much. Okay, and we know that it's 135 degrees. Now, they tell us that AB is equal to 8 kilometers. So I'll write that out. It's 8 kilometers. And we know that AC is equal to 6 kilometers. So it's slightly shorter. The vector or the line is slightly shorter. We want to know what the bearing of B from C is. So before I get started on anything, I'm definitely going to do my line of C to B or B to C. And the next thing I'm going to do is I'm going to show that we are looking for the bearing of B from C. So the bearing of B from C means that we are starting at C and we are going towards B. So that this angle measure right here is what we're looking for, from C going towards B, which is the pink line. Now, in doing that, we're not given a lot of information here, but the first thing that we always want to check on these problems with the bearings is to see whether we have a 90-degree triangle or not. So the one thing we can certainly do is say, well, using the parallel lines and the transversal, if the angle here from B is 45 degrees, then that means that the internal angle inside here is going to have to be 135 degrees. So if the angle here is 135 and the angle A that was given to us in the bearing, when we looked at the bearing from A going towards C was 135. So 135 plus 135 certainly gives us 270 degrees. And if I subtract that from 360 degrees, so if I do 360 minus the sum of those, that will give me a 90-degree angle. So 360 minus 270 gives us 90. So I definitely know at this point that the angle internally of my triangle is going to be 90 degrees. All right, in knowing that, simplifies our life a great deal, because if we are trying to find the bearing of B from C, well, it becomes a lot easier. Now, what we can do then is we can say, here is my angle theta. Now, we have the information of the lengths of two sides of this 90-degree triangle. So using the trigonometry rules, or the rules of the sine, cosine, and tangent, I can take a look at this and say, with respect to the angle given, it is opposite over adjacent. And the opposite over the adjacent is nothing more than tangent. So I'll say that the tangent of angle theta is going to equal 8 divided by 6. That my opposite is 8 and my adjacent is 6. I now bring the tan inverse. I'm going to do the tan inverse of 8 over 6, because remember, we have been given the ratio and we are now looking for the corresponding angle to that ratio. So using the calculator, I very quickly insert the given angle and the given ratios, and I say second function tangent of 8 divided by 6, close the parentheses, equals, and I get 53.1 degrees. Now, because we are looking for the angle C here, as you could in green. Now we also know that our angle theta now is 53.1 degrees, but we still need to figure out what angle alpha is, which I have just written out, our angle alpha. And that's easy to find simply because we have two parallel lines with respect to north. So we have the red line with respect to north and the green line with respect to north. And therefore, we know that if this angle is 135, then this angle must be equal to 45. And because the two angles here added up together and subtracted from 360 will give us our angle C, we can say, therefore, that the bearing from C towards B is going to be the 360 degrees minus the sum of the 53.1 degree angle plus the 45 degree angle that we found from the parallel lines in the transversal, so that when we add those up and subtract them from 360, I can do 360 minus 53.1 and then minus the 45, and that gives me 261 approximately, or approximately 262 degrees. It was 261.9 degrees, but if we want to place it to three significant figures, it'll go to approximately 262. Okay, so that will give us our solution to the problem we just looked at. All right, the last example we're just going to look at is an airplane that departs A and flies on a 143 degree course for 368 kilometers. It then changes direction to a 233 course and flies a further 472 to a town C. Okay, so what we have is a plane that's departing. We have a plane that's departing from town A, I suppose, and it goes on a course of 143 degrees. So 143 degrees, approximately like this. And it stops, okay? And it does that for 368 kilometers. So there's our 143 degrees. Now, it changes direction, again, with respect to north. So with respect to north, it changes its direction, and it goes on 233 degrees. So 233 degrees is approximately as such, and it does that for 472 kilometers. So we're going to make that a little bit longer than the other vector. And this is going to be at 233 degrees. Okay, now what we want to do in part A is we want to figure out what is our distance and from C to A. So we're looking from our end point to our starting point. So this was our starting point, and here is our end point. Start, and we're going to put finish here. Okay, so the first thing we want to do is we want to make sure that we have a 90-degree triangle to deal with, because if we do, it's going to make things a lot easier for us. So that I'm going to quickly measure and say, okay, well, I know that with respect to here, we've got, that's north and north, there's our transversal crossing through, so that if I do 180 degrees minus 143, that's going to give us an angle of, I'll do that in red, of 37 degrees. So I said 180 minus 143 degrees will give us the angle internally of 37. So we know that that angle is 37. When I now add 233 plus 37, and if I subtract that from 360, it should give us a 90-degree angle, or and so that we will be able to use the Pythagorean theorem. So 360 minus 270 is definitely giving us a 90-degree angle. So we've confirmed that this is a 90-degree angle. So in solving now for part A, the distance of C from A, we're looking for the hypotenuse. And in finding the hypotenuse, all we're going to do then is take the two sides that were given to us. So we were given two sides, and so we can say with respect, we can say that AC, or the final length of the hypotenuse AC squared, is going to equal 368 squared plus 472 squared, and we end up getting 360, I'm just doing the calculation here, of 599 is going to be approximately our length of AC. So it's approximately 599 kilometers. All right, now having been told that, we are now looking for the bearing of C from A. Okay, so the bearing of C from A is going to result in the blue angle that I am drawing out now, starting at A with respect to north, going towards C. Now, we have part of that angle. We know that part of that angle is 143 degrees, but we need to figure out the angle internally here, theta, to then add them up to find our bearing of C from A, so that the plan is to say the bearing of C from A would be equal to theta plus the 143 degrees. But before we can do that, we need to figure out theta. And we can figure out theta by using the ratios of the lengths of the sides once again, so that I could say opposite over adjacent. So with respect to the angle theta, if we do opposite over adjacent, it's going to be the tangent of theta equals 472 divided by 368. And theta will equal the tangent inverse of 472 over 368, which is equal to 52.1 degrees. So our final statement then here is going to be 52.1 degrees. Therefore, our bearing is going to be theta plus, we said 143 degrees, so it becomes 52.1 plus 143 degrees, and that ends up giving us 195.1 degrees, and that would be our bearing of C from A. All right, that's the end for today. See you next time.